All right, let's jump straight into this explainer and tackle something we all universally dread: the midnight furnace failure. Seriously, we've all been there, or at least we've all had nightmares about it, right? You wake up, you're freezing in the middle of January, or you're just sweating through your sheets on a sweltering July night, and you realize your home's climate control has completely given up the ghost. Well, today, we're going to demystify the whole thing and learn the real rules of the HVAC game. We'll break down exactly why these systems fail, what warning signs to watch out for, and how to make the smartest financial decision when you're finally forced to replace your equipment.
So here's how we're going to break this all down today. First, we'll look at when HVAC systems fail. Second, why these breakdowns happen based on climate and construction. Third, the common heating and cooling culprits. Fourth, the $5,000 replacement rule. And finally, the realities of HVAC upgrades. Let's get into it.
Starting off with Section 1, when HVAC systems fail, and the reality of extreme weather breakdowns. This is absolutely the pain point we all fear the most. Because the reality is, extreme temperature swings simply do not care about normal business hours. When summer humidity pushes your air conditioner into overdrive, or when those winter temps just plummet below 20 degrees, your system is forced to cycle constantly. It's working overtime. This extreme load pushes your equipment to the absolute brink exactly when you need it the most. Breakdowns rarely happen on a nice, mild Tuesday afternoon, do they? No way. It happens at 2 a.m. during a massive blizzard or a record-breaking heat wave. So when that crisis hits, you really should expect a simple 3-step action plan from a local 24/7 expert, like Grand HVAC out in Columbus. First, you call and schedule. You need immediate dispatch, not just leaving a desperate voicemail. Second, a technician arrives with a fully stocked truck. They give you an upfront diagnosis and get your written approval before doing anything. Third, the repair and testing get completed, often on the exact same day because they've already got the parts on hand. Knowing this process is out there, honestly, takes a huge amount of the panic out of a late-night emergency. Moving right along to Section 2, why breakdowns happen here, looking at climate and construction root causes. Now, what's really fascinating about this part is how your home's actual foundation and its history totally dictate your specific HVAC vulnerabilities. Whether your house is a century old or it went up during the housing boom in the 90s and early 2000s, every single construction style has its own unique flaws. For example, older historic properties, they often have massive, oversized legacy equipment that was installed decades ago. It just short cycles and wastes tons of energy. But on the flip side, newer builds from those rapid expansion periods frequently suffer from undersized air returns or really poor zoning systems. And that right there is exactly why you might have a freezing living room downstairs, but perfectly stuffy hot bedrooms upstairs. And I find this next point absolutely fascinating. The very ground beneath a home can actually sabotage its airflow. In places like Franklin County, for instance, the local clay-rich soil causes foundation settling over time. So as the house naturally shifts, it can literally pull your ductwork apart right at the seams. What does that mean for you? It means all that perfectly conditioned air you're paying for is just leaking out into your crawlspace or your attic. It destroys your system's efficiency and totally drives up your utility bills. Okay, let's transition into Section 3, common heating and cooling culprits, and identifying the warning signs. We're going to look at the specific hardware failures that these environmental and structural stresses actually cause, so you know exactly what to keep an eye out for. When extreme weather really overwhelms your system, these are your usual suspects. You might see frozen evaporator coils, which usually happens from restricted airflow or low refrigerant. Then you've got clogged condensate drains, where algae builds up, blocks the flow, and triggers a safety switch that completely shuts the whole system down. You could also face failed capacitors, meaning your compressors simply can't get that initial electrical spark it needs to start running. And then there's the heat exchanger. Let's pause here for a second because this one is absolutely crucial. A cracked heat exchanger happens when years of repeated heating and cooling cycles just stress the metal to its breaking point. And this isn't just a basic efficiency issue, it's a huge safety hazard. It risks deadly carbon monoxide mixing directly with the air circulating in your house. So while a clogged drain is just annoying, a cracked heat exchanger is highly dangerous. If this happens, it mandates an immediate, full replacement of the furnace. No quick patch jobs here, it's literally a matter of safety. And that brings us perfectly into Section 4, the $5,000 replacement rule, which is the ultimate financial guideline. We are now at the most critical part of this explainer, how to make that incredibly stressful financial decision when a technician hands you a massive repair quote. Repair or replace? It's the burning question every single homeowner absolutely dreads facing when their system breaks down. Do you sink more of your hard-earned money into an aging machine, or do you bite the bullet and invest in a brand new one? Well, the answer really comes down to this exact number, $5,000. Seriously, write this down, put it in your notes app on your phone, because this number is going to be your new best friend when you're evaluating any HVAC estimate. This rule takes a highly complex, often emotional decision and turns it into very simple, empowering math. Here's how it works. You just multiply the age of your system by the repair estimate. So, let's say you have a 12-year-old system and the quoted repair is going to cost $500. Well, 12 times 500 equals 6,000. Because 6,000 is greater than 5,000, replacing the system makes way more financial sense. It's a brilliant little formula to help you avoid throwing good money at a dying machine. Of course, to use the $5,000 rule accurately, you kind of need to know where your equipment actually sits on its life cycle. Heat pumps typically last about 12 to 15 years, mostly because they're running year-round for both heating and cooling. Air conditioners, they average 15 to 18 years, and furnaces, they can often reach up to 20 years if you've kept up with proper maintenance. But once you hit these age ranges, efficiency drops dramatically, and those annoying breakdowns become way more frequent. All right, let's move into our fifth and final section, the realities of HVAC upgrades. We're going to navigate codes, sizing, and costs. If the $5,000 rule tells you it's definitely time to replace, here's what you actually need to know going into that whole process. First off, one of the biggest mistakes homeowners make is relying purely on the square footage of their home to buy a new AC or furnace. It's a massive trap. A true professional upgrade requires strict manual J load calculations and manual D ductwork calculations. They actually have to factor in your insulation levels, your window area, ceiling height, and even the orientation of your house to the sun. If someone is just guessing the size, you'll likely end up with an oversized system that short cycles or an undersized one that never quite cools down the room. Next, let's talk strategy, because when it comes to HVAC, timing is literally everything. Buying during the mild shoulder seasons like fall and spring is absolutely ideal. Contractors have less demand, better availability, and they're often running promotions. But if you wait until a heat wave in July or a deep freeze in January, you're going to run into peak demand, technicians who are booked solid, and those painful premium rates that come with emergency winter or summer replacements. Now, while modern systems bring incredible technological advancements, they also come with some pretty strict building codes. For starters, that older R22 refrigerant has been phased out by the EPA, making it wildly expensive to repair old units. Modern systems use R410A, which requires completely new high-pressure components. You'll also run into higher baseline efficiency minimums, known as CR2 and HSPF2, which are essentially high standard efficiency scores. So yes, it means the tech is better, but it does cost more upfront. However, and this is a big however, under the 2025 Inflation Reduction Act, you can get up to 30% in tax credits on qualifying equipment, and that significantly softens that upfront investment. So I'll leave you with this final thought to ponder. Will you wait for that dreaded midnight breakdown, or will you take control of your home's climate today? Understanding these root causes, knowing the warning signs, and applying that $5,000 rule gives you the power to act before the crisis hits. Don't let your comfort or your wallet be left to chance. Thank you so much for joining me for this explainer, and stay comfortable out there.